So this video is about calculating pH and POH and what it is actually. So the pH scale goes from negative 2.1 to 16. Now you've probably always heard that it's 1 to 14, as the scale down here indicates, with 1 being very acidic, 14 being very basic or alkaline. So know that the word alkaline means basic. And then 7 is neutral, right? 7 is water. But there are some really strong acids that actually kind of break the scale and go past 1. So they'll go 0 and actually negative numbers. And there are some bases that can go past 14. So what the pH actually is it tells you how much H plus is in solution, or H3O plus. Remember, let's see here, I gotta get my pen. H plus and H3O plus are the same thing for this class. That's what we'll call it. And then the POH scale, there is a POH scale, is 0 to 14. Well, actually, it can go a little higher and lower as well, but it does give the relative strength of the OH concentration. So we'll learn what the actual P and the H mean here in a second. The H refers to the H plus concentration, and you're going to see that the P stands for the negative log, which is coming up here, which we actually have the equation here. pH is the negative log of the H plus concentration. So some common substances, hydrochloric acid, your stomach acid is a pH of 1. You got lemons, vinegar. You can see these are all acidic things. Water is a 7. Blood is just slightly basic, somewhere in I think the 7.4 to 7.6 range. It just lists it as an 8 here. Baking soda, you'll see a lot of your cleaning products, drain cleaners, very basic. Bleach, soap are also a little bit basic. And then you got ammonia, and then milk of magnesia, which is used to neutralize stomach acid if you have an upset stomach. Some important equations, write these down. I'll actually just put them all up on the screen here. What I want to point out before you write them down, though, is you'll see these square brackets. What the square brackets mean is concentration in molarity. So the pH is equal to the negative log of the concentration of H3O plus. So the square brackets mean concentration of whatever's inside, and concentration is in molarity, which we should be familiar with now. And then POH is the negative log of the OH minus concentration. Then how are these two related? Well, they're related. pH plus POH equals 14. Or H3O plus concentration times the OH minus concentration is equal to 1 times 10 to the minus 14. So if you know either pH or POH, it's always possible to get the other one by just rearranging this equation, doing 14 minus the one that you know to get the one that you don't know. A few other things. I've already mentioned this. Acidic things have a pH between 1 and 7. And again, some of them can break the scale, go less than 0 to the negative side. And then neutral is 7. And then basic is a pH of 7 to 14, or sometimes bigger than that. So let's do an example calculation here. What is the pH of a 0.1 molar solution of HCl? Now we know that HCl is a strong acid, so when it breaks up into H plus Cl minus ions. So if we've got 0.1 molar concentration of this, 100% of that breaks up into these ions. That means that we actually have none of this left over, and it all turns into this. So we actually end up with 0.1 molar of each of these different ions. So why is that important? Well, that's important because the pH is equal, there it is. pH is equal to the negative log of the H3O plus concentration. Remember, this is the same as the H plus. So now I know that my H plus concentration is 0.1 molar. So now all I have to do is say, okay, pH equals negative log of 0.1 molar. And you plug that into your equation or your calculator. So you type the negative, and now make sure on your calculator there's a minus and a negative button if you have a Texas Instrument. The negative is right next to the enter, depending on which model you have. So I go negative log, I hit the log button, and then I go 0.1, and I get a pH of 1. Now there are no units on this, it is just pH equals 1. So a 0.1 molar solution of HCl will have this pH. So it is very acidic. What is the pH of a 0.001 molar solution of HCl? You should pause the video, try this on your own. It's very similar to what we just did. So again, remember HCl breaks up into H plus and Cl minus. So again, all of this is gone. So that means that the concentration of H plus is 0.001 molarity. So I plug that into my equation. pH equals negative log. So I had to pause it there, so I'm back now. Negative log now of the H3O plus concentration, which we know is this. So you put 0.001 molar in there. Again, type it into your calculator. Negative log 0.001 equals, and that's a nice clean 3. So there we go. If we have a more dilute solution of acid, because the last one was 0.1 molar, that gave us a pH of 1. This one gives us a pH of 3, so notice that the more dilute the acid is, the further up this way it goes on the pH scale, so it's less acidic. This is more acidic, this is less acidic. So now we got another one though. This one, I wouldn't recommend pausing this one and trying it, because this one's got a new twist to it. I'll have you watch this one first. The big difference here is that this is a base, this is an acid. This isn't an acid, so you can't just plug this into the negative log of the H plus concentration anymore, the H3O, because this isn't an acid anymore. So now NaOH, when it breaks up into Na plus and OH minus ions. Now remember, this is a strong base, so that means none of it is left. That means all of it turns into Na pluses and OH minuses. So now I know my concentration of OH minuses. So if I know the concentration of OH minus, I should use this equation. Notice this is the POH equation, not the pH equation. So let's plug this in. POH is equal to negative log of the OH concentration, which is 0.001 molar. And that should be the same as last time. It should just be a 3. Now you're like, oh, but we got the same answer. No, we didn't, because this is the POH, and this is asking for the pH. So now we have to use another equation. pH plus POH equals 14. So now I'm going to take 14 minus the POH, minus 3. So 14 minus the POH. And that will tell me what the pH is. And you can probably do this one in your head. 14 minus 3 is equal to 11. So the pH is 11. And you should ask yourself, does this make sense? And the answer is yes, because 11 is right here. I added a base. So if you add a base, and let's say that you forgot to do this last step, and you're just like, oh yeah, my pH is 3. Well, 3 is an acidic pH. How did I get an acid out of a base? So then you got to remember, oh yeah, I forgot this step. I have to convert POH to pH, and then pH is 11, which is a basic value on the pH scale. That makes more sense. If I add a base to water, I should get a basic pH, right? So always be thinking about that in your head as you do these problems. Does your answer make sense? For this this slide, what we're going to do is we're just going to fill this in. I'll do the first row, and I'm going to let you do the next 2 rows on your own. So just remember a couple things here. pH plus POH equals 14. So you can, if you know one of them, you can get the other one. And then remember that this OH concentration times this equals 10 to the minus 14. I don't know if nope, okay, I didn't put the equations in there. So you can get one or the other that way by using this equation here. And then to get from pH to like to OH concentration, you just take 10 to the minus pH. So I'll do an example there. Or to do this, you just go 10 to the minus POH. That's one way to get back and forth. And then you know how to go the other way. To go the other way, you just take the negative log of the H3O plus concentration, right? So if you want to go this way, you take the negative log of this. So let's do an example here. That's a lot of kind of messy stuff there. So I know that this plus this equals 14. So I'm going to go 14 minus 2.45. 14 minus 2.45. And that's going to equal 11.55. So I know my pH is 11.55 if my pH is 2.45. Now to do this, let's go from here to here. I am going to take 10 to the minus 11.55. So let's type that in, 10 to the negative 11.55. And what I end up getting is 2.82. 2.82 times 10 to the minus 12 molarity. So that's my concentration of H3O plus. And you'll have to get used to using numbers in scientific notation because your numbers are going to be either really big or really small, depending. Well, actually, they're almost all really small. Sorry, not usually big in this case. Now I could do 10 to the minus 14 divided by this, but that seems like a lot of typing in my calculator. So I'm just going to go 10 to the minus 2.45 to get my OH concentration. 10 to the minus 2.45, and you end up with 0.00355 molarity. And you can always check, does this times this equal 10 to the minus 14? And it should. So again, we could actually, I'll do this next one here. I'll go from here to here for you. I know that this times this equals 10 to the minus 14. So I'm going to rearrange that and say 10 to the minus 14 divided by 0.01 equals my OH minus concentration. So let's type that in, 10 to the minus 14 divided by 0.01. You may want to use parentheses if you're typing them in scientific notation, just to make sure that you're not making a mistake on that, because sometimes the order of operations can get goofy on you. So when I typed in this, my OH minus concentration, I got this. So from there you can do the negative logs to get this. I'll let you do the last one on your own. And there are a couple other problems in here. But at this point you should be able to do these, so give these a try on your own. So these are in your note packet. I will let you try these, or we can do them in class. Or I might actually I think I'll make one more video here and make one more video on these.